Hello, and as always, thanks for stopping by. Today I want to take a look at that Aussie signal tracer that Doug over at Mosslack's been working on. At first glance, it looks like a fairly normal signal tracer schematic here looking at it. You have an op amp on the one side to take and amplify your incoming signal, and then an audio amplifier on the other side to take and boost it up so that you can take and hear it. Uh, I've seen a lot of signal tracer circuits this way. Don from Restore Old Radio, his is basically this way. He uses a 741 and a 386. Now this one uses an LM318 because the author is talking about uh, being able to use the 15 megahertz bandwidth. I don't know whether he was using this as a radio or what, but you're certainly not going to be hearing anything, well, for me, probably above 10,000 uh, hertz, and definitely, for anybody else, above 20,000 hertz. So I have no idea why he figured that he had to take and amplify uh, that type of signal just to get the audio out of it. But if you take a close look now at the circuit itself, the first thing you notice is that coming in, there's 100,000 or there's 100,000 ohm resistor to ground. Well, that's your input impedance. Now, most signal tracers have an input impedance, at least 1 meg, if not, well, like mine is, I think, 2.2 meg. So you're not loading down the circuit that you're probing, and to take and keep the signal as high as possible. And the other thing is, there's no real volume control on it. I mean, there's low, medium, and high signal or whatever. But if you look on the audio side there, okay, he amplifies the signal, and then he takes it and runs it through a 100K resistor with a 3.3K resistor to ground, which he calls the 30 dB attenuator. Now, why would you want to boost the signal and then attenuate it? It doesn't make sense. And even if you look at the part of the description here that he has, okay, low gain is a 6 dB boost. Okay, so figure, okay, you're boosting at 6 dB, and then if it's an audio signal, then you're taking it down 30 dB, so you're going to be 24 dB under what your input signal was. And even at the other two, at medium, okay, you're at 20 dB. At high, you're at 38 dB. So it just, I could not understand exactly what he was doing. Running some tests on it now. Okay, this is the signal I was feeding in to begin with. It's a 10 millivolt, 1000 hertz tone, and that was coming out, being reproduced faithfully or whatever, with 10 millivolts in on the low setting. I was getting 14 millivolts out of the speaker connection. On medium, I was getting 70 millivolts, and on high, I was getting 267 millivolts. So that's a decent gain, but there again, you're low. You're almost like getting the same signal that you're putting in. Then I took it, I raised it to 100 millivolts for an input signal. Now with 100 millivolts going in the low setting, I was getting 102 millivolts out of the speaker. So basically getting out exactly what I'm putting in. On medium, I was getting 720 millivolts, and it was starting to distort a little bit, as you can see in this picture here. And then on high setting, I was getting 2.7 volts out, which I mean, it's still you can take and hear it. It's but they're getting we're not looking for pure audio here. So to me, that is still acceptable signal. Now anything much over that, I took and went up. Then I took and raised the signal to half a volt. Uh, Now these are all RMS measurements, a half a volt RMS going in. Coming out, I was getting half a volt RMS, as usual. And then what's happening now is that we're starting to drive the LM3 386 so hard that it like hits a limit. You're only getting in medium, you're getting 3.2 volts out. On a high, you're getting 3.8 volts out. So, you're not going to notice any difference, on a strong signal, you're not going to notice any difference between medium and high. And like I was telling Doug, with this low, medium, and high stuff, reminds me of the old radios. The old radios on the tone control, they used to just take and wire 2 or 3 capacitors in, and you'd have like one setting was labeled voice, one was labeled music, and one was labeled short wave. And there was no real adjusting of the bass and treble or whatever. You just had to take and put up with whatever those 3 capacitors did. And I'd rather be able to take and vary my volume here so that I can take and use the maximum gain and then regulate the volume coming out of the speaker with the volume control, rather than just have to take and put up with the 3 settings that he had. So what I did is I took and went in and I took out that 30 dB attenuator that he had, and took and broke the circuit right there, and took and put a 10K pot in for a volume control. And then I just took and wired the LM386 into the high position, basically, and I replaced the 1 microfarad capacitor with a 10 microfarad capacitor. And I left the low, medium, and high for the LM318 as is, for low signal or whatever. You have adjustable gain there, so there's no trouble. And to me, this is a lot more viable, I guess you'd say, more usable signal tracer than the way it was originally drawn up. As far as sensitivity-wise, I'm going to make another video comparing the sensitivity of this with 2 other signal tracers. It's not bad. It's not the best. And I think part of that is that 100K resistor. I may take and play around with that and see whether the sensitivity improves if I take and raise that up to a meg or so. But I just wanted to get this out quick and just take and show my findings in testing this. And it's not really a circuit I would take and recommend. To me, it's got too many flaws in it. There's a lot better circuits out there. So anyway, thanks for stopping by, and in a day or so I'll have that other video out comparing the sensitivity of 3 different tracers. This will be one of them. Thanks for stopping by, and have a good day.